Think about organizing a train journey with friends. Each stop is carefully planned, and the train follows a specific route, moving systematically from one station to the next. Just like in a well-organized trip, each step in this journey needs to happen in a specific order to ensure everything runs smoothly. This concept of ordered movement helps illustrate how linked lists operate in programming. This video will cover the basic concept of a linked list and how it organizes data. It will explain the differences between singly and doubly linked lists and demonstrate how linked lists offer flexibility and efficiency in managing dynamic data. So what exactly is a linked list? A linked list arranges information in a sequence, similar to stations along a train route. However, instead of stations and tracks, a linked list is made up of nodes and their connections. In programming, linked lists provide a flexible way to manage data, allowing for easy insertion and removal of elements without rearranging the entire sequence. In a train journey, the train departs from the first station and continues to the next, progressing through each station until reaching the final stop. Similarly, in linked lists, each node follows the sequence like a station along a flexible path. Each node holds data and a reference to the next node, much like the station has a name and details about the next stop. Each node consists of one or more data parts, taken to be a single data unit, and one reference part, in case of a singly linked list, or two reference parts, in case of a double linked list. These references are sometimes referred to as pointers, since they point to another node. This structure maintains the sequence, ensuring it stays intact and efficient. Assume that each station master, or head of a station, knows only about the route to the next station and gives this to the train driver on reaching a station. If this is the case, then the train journey to travel among the different stations is a fitting example of a singly linked list. In a singly linked list, each node is aware only of the next node in the sequence. Once a train leaves a station, it no longer interacts with the previous stops. This one-way flow is what characterizes a singly linked list. On this journey, there's no turning back, only moving forward to the next node in the sequence. Doubly linked lists, in contrast, resemble a route where both the station master, or head of the station, has information on both the next and previous stations. Each node has two pointers, one pointing to the next node and the other to the previous one. This two-way connection enables movement in both directions, making it easier to navigate the list or make changes from either end. Note that the first node's previous pointer will typically be null, as there's no node before it. So, why use linked lists instead of something simpler like an array? The advantages that linked lists offer over arrays are dynamic size or flexibility, and efficiency in assertions and deletions, no wastage or shortage of memory, all of which are important when manipulating sequences of data. For instance, if you need to add a new station to the planned route at the last minute, it's similar to inserting a new node into a linked list. An array is like having all the stations on the route lined up in a fixed order, so adding a new station would require shifting all the others to make space. This process can be time-consuming and disruptive. With a linked list, you can simply update the references in the nodes. This makes manipulating linked lists quicker, easier, and less disruptive to the overall sequence. If you're working with a list where data is frequently added or removed, linked lists are an ideal choice. Take, for example, a playlist of songs where tracks are regularly added or removed. With a linked list, you can effortlessly insert a new song at any point in the playlist, without needing to rearrange the entire list. Another example is a to-do list app, where tasks are frequently added and completed. A linked list efficiently manages these tasks, allowing you to easily insert a new task in the middle of the list or remove one when it's completed. More specifically, single linked lists are ideal for situations where data needs to be processed in one direction, such as handling a queue of tasks, where each task must be completed in sequence. On the other hand, doubly linked lists are well suited for scenarios where you need to move in both directions through your data, like moving backward and forward among the train stations. To recap, a linked list is comparable to a well-organized train journey. Each node, or station, holds data and has a reference to the next stop. In singly linked lists, each node only knows about the next one, whereas doubly linked lists reference both the next and previous nodes. Understanding linked lists gives you a powerful tool for efficiently managing dynamic data. Whether it's a playlist, a to-do list, or any other data sequence, linked lists help you handle changes smoothly and keep everything running efficiently.